Welcome to the Deep Dive. We're here to cut through the noise, get past the headlines, and really pull out the important insights from, well, a whole stack of sources, just for you.
That's right.
Today we are tackling something huge, a transformation that's not just theory anymore, it's really reshaping the daily work of millions. We're talking about the impact of AI, specifically large language models, on software development.
Yeah, absolutely. And we've got some really insightful material here. Think of it as a kind of strategic report mapping out how AI is fundamentally changing the game for building software. And like you said, this isn't about someday, it's happening right now.
Right now.
We're diving deep into the practical shifts, and developer workflows, team setups, even the architecture of the systems themselves, plus those critical questions around quality, risk, and even how we bring talent into the field.
So our mission for this deep dive, really, is to unpack the key takeaways from this material. We want to get a handle on what AI means, not just for software as some abstract idea, but for the developer sitting at their keyboard today, for the engineering teams trying to ship reliable stuff.
And for the strategy of the companies building the tech.
Exactly. It's about grappling with the fact that AI isn't just tweaking things, it's creating entirely new ways of working.
Absolutely. You could think of this as your essential guide to understanding just how big this shift is, and it's all based directly on the analysis in these sources. We're going to explore how the core act, writing code, is being revolutionized.
Good.
We'll look at the surprising twists this brings for productivity, how the systems we build are becoming intrinsically linked with AI, how roles on dev teams are evolving in significant ways.
Just a big one.
Oh, yeah. And the new, really complex challenges this creates for making sure things actually work reliably. We'll also touch on how top companies are moving beyond just using public tools. They're building their own AI capabilities internally. Yeah, and how the whole landscape for finding and integrating new talent is changing, and maybe most critically, the risks involved and the essential guardrails you absolutely need to navigate this new world safely.
Okay, let's jump right in then. Let's unpack that very first foundational shift the source material talks about. The one that's probably the most visceral for any developer listening. The actual act of writing code. The source says daily life in the IDE is fundamentally changing, right? It's moving away from that classic picture, crafting code line by line from scratch.
Exactly. That's the core idea presented. Software development is quickly shifting from primarily writing code, typing it all out, to a process that's more about composing, curating, and prompting.
Composing, curating, and prompting.
Yeah. LLMs are becoming so deeply embedded in development tools that the whole interaction feels different.
That phrase, composing, curating, prompting, it really feels like the headline for this new era, doesn't it? How does that actually play out day to day for a developer based on this material?
Well, the source talks about how the integrated development environment, the IDE, is evolving. It's not just, a fancy text editor with some basic autocomplete or syntax highlighting anymore.
Right.
The modern AI-powered IDE, it can do real-time prediction of pretty significant code blocks. It can suggest entire functions, classes, maybe even small modules, just based on the developer's context, their comments.
Wow.
It can also help explain code that's already there or suggest ways to refactor it. You're basically interacting with the code at a much higher level, semantically speaking.
So instead of me painstakingly typing out all the boilerplate for some common function or trying to remember the exact parameters for an API call I use all the time, the AI just pops up the whole thing. And my job becomes more about saying, yeah, that looks about right, or, no, tweak this bit here.
Precisely. That's the composing part, assembling these larger AI-generated pieces, mixing them with your own logic, fitting them into the existing code. Then there's curating, which is arguably the most critical new skill here.
Okay, curating. What's that?
It's that essential, diligent review. It's validating and refining what the AI spits out. Because, and we'll definitely get into this more, the AI isn't perfect. Not by a long shot. Its output needs really careful checking to make sure it actually meets the requirements, hits the quality bar, and crucially doesn't introduce new bugs or security holes.
Right, because it might look right, but be subtly wrong.
Exactly. And then prompting becomes a primary way you interact. You need to get good at clearly and effectively telling the AI what you intend, what you need, guiding how it generates the code.
That sounds like a complete shift in where a developer puts their mental energy, less focus on the muscle memory of specific syntax and library details, and more on understanding what you actually need, how to ask the AI for it effectively, and maybe most importantly, how to critically evaluate what it gives you back.
It's a really profound change in the cognitive load, yeah. And the source makes a strong point here. This doesn't make developers obsolete, not at all. Instead, it sort of elevates them into this role of software composer or maybe system orchestrator. They're operating at a new, higher level of abstraction.
A new layer of abstraction. The source draws a comparison there, right? Can you expand on that?
Yeah, think about how programming languages have progressed over time. We started way down low with machine code, then assembly language, very fiddly instructions tied right to the hardware.
Super low level.
Right. Then came higher level languages, C, then Java, Python, JavaScript, and so on. Each step abstracted away more of the underlying complexity. It let developers express more powerful ideas with less code, focusing more on the logic and less on the machine's nuts and bolts.
Okay, see the pattern.
The source suggests LLMs are basically introducing another layer like that. You're not necessarily writing all the low-level details in Python or Java yourself anymore. You're interacting at a layer above that high-level language, prompting the AI to generate that language based on your higher-level intent, your description of what you want done.
So it's like moving up another rung on the ladder of telling the computer what to do. You describe the desired outcome or the function you need, and the AI does the translation into the actual lines of code. But the developer is still absolutely essential for that high-level design, for expressing the intent correctly, and for that crucial validation of the output.
Absolutely. The emphasis shifts. It moves away from the mechanics of crafting individual lines of code towards the architecture, the integration, the validation of these generated components. And this fundamentally changes the rhythm of coding, right? If you can generate big chunks of code much, much faster, well, what does that imply for the overall pace of development?
Yeah, that speed aspect. It's the natural lead-in to the second major area the source explores, the impact on productivity and what it calls the productivity paradox.
Right, and this is where, the initial excitement maybe meets a bit of a reality check. The source definitely confirms that tools like GitHub Copilot, for example, do demonstrably increase output velocity. Developers can generate code faster. There's no question about that.
Okay, so the speed is real. Where do we see those gains most clearly in practice?
The source points to areas like generating boilerplate code, the repetitive setup stuff, implementing common repetitive patterns, drafting initial versions of functions, or maybe unit tests based on the code around them.
The tedious bits?
Exactly. Tasks that are common, often kind of boring, and follow predictable structures, AI is really good at spotting those patterns and reproducing them quickly. So instead of manually typing out standard class definitions, import statements, basic API calls, the AI can often just whip those up instantly.
Okay, so the busy work, the mechanical typing part, gets significantly cut down. That definitely sounds like a productivity boost. But you called it a paradox, which implies there's a catch. What's the downside the source is highlighting here?
This is the really critical insight, I think. The danger lies in building the wrong thing, just faster. You can absolutely pump up the volume of code produced per hour, no doubt. But if that code is buggy, if it's insecure, if it doesn't actually fit the system's real needs, or if it just introduces a ton of technical debt down the line, then that speed isn't just worthless, it's actively harmful.
Wow.
You've basically just accelerated your journey towards a really problematic outcome.
So the paradox is that speed without the right direction, without the intelligence or context, just leads to faster failure, or faster problems anyway.
Essentially, yes. And the source gives a pretty compelling example related to this. It talks about teams using AI tools who might see, say, an increase in the number of pull requests being generated and merged. On the surface, that looks like higher output.
Yeah, more changes getting done.
But at the same time, they might observe an increase in the number of bugs being reported later, or a growing need for significant rework down the road.
Oof. That's a very concrete example of the paradox. More code changes happening, but leading to more problems. How does the source explain why that happens? What's the mechanism there?
It ties directly back to that curating step we talked about, the critical review. The AI generates code based on patterns it learned from its massive training data set, and the immediate context you give it your prompt, the surrounding code. But it lacks the deep, nuanced understanding of the entire system.
It doesn't know the whole picture.
Exactly. It doesn't grasp the specific business logic nuances, the implicit non-functional requirements like performance targets or specific security postures or, the long-term maintenance headaches a certain pattern might cause. That's stuff a human developer brings. The code it generates might be syntactically perfect, it might even pass some basic tests you throw at it, but it could easily miss crucial edge cases, interact badly with other parts of the system, or rely on assumptions that just aren't valid in your specific project context.
And if the human developer reviewing that code is maybe too focused on the speed benefit, or just doesn't perform a rigorous enough context-aware check, then those issues just slip right through.
Yeah.
Maybe the developer trusts the AI a bit too much, or maybe their review process simply hasn't adapted to the unique challenges of reviewing AI-generated code.
So the key takeaway from the source here is absolutely crucial. Those velocity gains you get from AI. They only translate into actual, valuable productivity when they're paired with other critical factors. Things like really robust quality assurance, thorough validation of what the AI produced, and strong team alignment on how these tools are used and what quality standards are absolutely non-negotiable.
This really reframes what productivity even means in this new AI-assisted world, doesn't it? It's not just about lines of code per day anymore. It's about delivering reliable, correct, maintainable features effectively.
Right.
So how do organizations make sure that this AI-driven speed actually contributes positively instead of just creating a faster path to technical debt or a buggier product?
It really demands a deliberate shift in focus, in process. It means investing more in automated quality checks, maybe enhancing code review practices to specifically look for common pitfalls associated with AI generation. And crucially, it means fostering a culture where developers truly understand the AI's limitations and their own responsibility in validating its output.
So the culture has to change too.
Absolutely. Measuring productivity might need to evolve as well. Maybe you start tracking metrics like bug escape rates or the cost of rework alongside just the volume of output. It's all about ensuring that curate step is strong and effective. You're accelerating the first draft, sure, but you absolutely cannot skip the editing and fact-checking phase.
That makes a ton of sense. Speed is only good if you're pointed in the right direction and not, digging yourself into a hole faster. And this necessary focus on quality, on context, it naturally leads us to think about how the very systems we build need to adapt when code can be composed this way.
Exactly. Which transitions us nicely into the third key area the source explores, architecture for the AI age. And the really significant point here is that AI isn't just a tool for building systems anymore. Increasingly, systems are being designed and built for AI.
Built for AI. Okay, this sounds like a pretty major philosophical shift in how we design systems. What does that actually mean in practice?
Well, it means the whole architectural process might not always start from a completely clean slate, where you design every single component and interaction from first principles before writing a line of code. The source suggests that in this new paradigm, you might actually begin with AI-generated scaffolding.
Scaffolding, like the AI provides the initial structure.
Yeah, the AI could provide initial architectural structures, maybe template code for common patterns your organization uses, or even basic frameworks for the whole system based on just a high-level description of the application you want.
So the AI helps lay the foundation or provides the initial skeleton of the system.
Potentially, yeah. But it goes beyond just that initial kickstart. The source really highlights the emergence of specific architectural components that are inherently AI native. These are parts of the system designed explicitly to integrate with, manage, and leverage AI models effectively.
AI native components.
Okay.
What kind of architectural elements are we talking about here? What's becoming important?
The source details a few key ones. First off, prompt APIs.
Prompt APIs.
Yeah. These are interfaces designed specifically for effective, reliable interaction with AI models. They might handle things like formatting inputs correctly for different models, managing those tricky context windows, handling streaming outputs smoothly, or maybe even orchestrating calls to multiple AI models behind the scenes. It's all about creating a robust, versioned way for the rest of your system to reliably talk to the AI.
Okay. So instead of just making raw calls directly to whatever LLM provider you're using, you build an internal layer, an abstraction that hides that complexity and standardizes how your application actually uses AI.
Precisely. You're building a structured interaction point that's tailored for AI consumption and output, rather than trying to shoehorn AI calls into traditional APIs that weren't really designed for it. Second big one, retraining flows.
Retraining flows, okay.
If your system relies on AI models whose performance needs to evolve or adapt over time, think customer support chatbots or content moderation tools, things like that, you need built-in architectural support for managing the whole retraining process.
Right, the models aren't static.
Exactly. So this means having mechanisms for collecting new relevant data, triggering retraining runs automatically or manually, evaluating the performance of new model versions, and then deploying them seamlessly into production, ideally with easy rollback capabilities if something goes wrong.
So you literally have to bake the AI's ongoing learning and improvement cycle right into the system's design itself.
Yeah, it becomes a core operational concern, not just some separate offline task you do occasionally. And the third key element mentioned is human-in-the-loop checks.
Human in the loop. That sounds important given the risks we talked about.
Very. Acknowledging that AI can make mistakes, that it can be fragile, especially thinking back to the productivity paradox. Architects are now deliberately designing points within the system workflow where human review, validation, or correction is required before the AI's output is fully trusted or acted upon.
So you're building systems that basically expect the AI to mess up sometimes,
Mm-hmm.
and you proactively build in ways for humans to catch those mistakes.
Yes. It's designing for resilience, acknowledging potential AI inaccuracy. This could look like many things. Maybe queues where AI-generated content waits for human review, dashboards that highlight outputs the system flags as needing human validation, or workflows that require explicit human sign-off at critical decision points.
Makes sense?
The source really emphasizes that architectural thinking now explicitly includes planning for these AI interaction patterns, for managing the model lifecycle retraining, deployment, monitoring, and for incorporating human oversight as integral components of the system, not just external operational procedures tacked on afterwards.
So the whole design philosophy isn't just about using AI as like another library you call. It's about building a system where AI is a first-class citizen, managed, validated, and integrated thoughtfully.
That's the core shift, yeah.
Mhm.
And it influences all sorts of choices, downstream data pipelines, monitoring strategies, error handling approaches, even UI UX design, because you might need to present AI outputs to users in a way that clearly signals this was generated or allows them to provide feedback easily.
And how does designing for these things, prompt APIs, human in the loop, checks, how does that influence the traditional architectural patterns we know, like microservices or event-driven systems or even monoliths?
Well, it pushes towards certain characteristics, right? You likely need more modularity so you can swap out AI models easily. You need robust data pipelines to feed those retraining flows effectively. You need flexible workflows that can accommodate those human review steps without grinding everything to a halt. It definitely requires careful consideration when making those core architectural choices.
Yeah, it seems like the architect's job is getting even more complex. Now they're integrating not just different software components, but also these external probabilistic AI models and these human oversight workflows all into one coherent system. So if the systems themselves are changing so fundamentally and the way code is written is changing, what does this cascade down to mean for the people actually building these systems? What happens to the familiar roles we see on development teams?
That's exactly where the fourth section of the source material focuses, and it's a really critical one for anyone working in this field. The core idea, as presented, is actually kind of reassuring in one sense. AI isn't seen as eliminating roles wholesale.
Okay, that's good to hear.
But it is undeniably reshaping them around new essential competencies.
Reshaping, not replacing.
Yeah.
Okay. How does the source describe these shifts, say, for different team members?
It gives a pretty good breakdown by typical role. Let's start with junior developers. The source suggests the change for them is profound. They might spend less time wrestling with, basic syntax errors or figuring out boilerplate code because the AI can often generate that pretty well.
Right, the AI handles the basics.
Yeah, so their focus shifts dramatically towards reading, understanding, and critically reviewing AI-generated code. They need to get really good at code comprehension, figuring out what the AI actually did, why it might have chosen that approach, and most importantly, whether it's correct, secure, and actually fits within the project's specific context. They become much more focused on debugging, refining, and integrating AI output.
Huh. So the entry point might seem easier in terms of just getting some code generated, but the demand for critical code review and deep understanding actually increases significantly right from the start.
Exactly. It's a shift in the foundational skill set. Less pure code generation, more code evaluation and integration. Now, for senior developers, the source sees their role evolving away from just writing huge amounts of code themselves towards becoming more like system orchestrators.
System orchestrators. I like that.
Yeah. Their value lies increasingly in understanding the overall system architecture, guiding the integration of both human-written and AI-generated components, managing the workflow where AI tools are used effectively, and ensuring the technical direction stays aligned with the product goals. They're responsible for making sure the whole symphony plays harmoniously, even when some sections are composed by humans and others are drafted by AI.
So they're less the master craftsman building every single piece by hand, and more the expert conductor making sure all the different instruments, human and AI, work together effectively to produce the right result.
That's a perfect analogy, yeah. Their focus becomes coherence, quality gates, optimizing the overall development process, which now includes this powerful AI assistance layer. Then for architects, as we kind of touched on already, the shift involves thinking in terms of AI-enhanced workflows.
Okay.
They're designing not just the application structure, but also how the development team interacts with AI tools throughout the entire software development lifecycle, from the initial coding and testing all the way through to deployment and ongoing monitoring.
So the architect is also designing the internal factory floor, in a way, making sure the AI tools are integrated smoothly and safely into the actual development process itself.
Increasingly, yes. It's about designing the system that builds the system, incorporating AI effectively. And the source also mentions product managers and designers. For them, AI tools can enable more direct interaction with the code base or allow them to generate prototypes and user flows much, much faster.
Right, speeding up the feedback loop.
Exactly. It accelerates that whole ideation and validation cycle. They could potentially use AI to quickly mock up different UI variations based on a description, generate basic data structures needed for a feature, or even draft initial API definitions based on written requirements.
It gives them exploration and communication superpowers almost.
Absolutely. They can explore more ideas more quickly. So the key takeaway across all these roles, according to the source material, is that the core value proposition for the human shifts. It moves towards judgment, synthesis.
Synthesis.
Yeah, the ability to take diverse outputs, maybe from different AI prompts or different tools, combine them with human knowledge and insights, and integrate them into a cohesive working system. And review, of course. Critical review.
Judgment, synthesis, and review. Wow. Those feel like much higher order cognitive skills than just being fluent in the syntax of a particular programming language.
They absolutely are. And this raises fundamental questions both for individuals and for organizations. What new skills suddenly become paramount for career growth, for team effectiveness in this AI-assisted world? How do you actually foster skills like critical thinking, effective prompt engineering, which is really a form of synthesis itself, understanding AI's common failure modes, and developing collaborative review practices that are specifically tailored for dealing with AI-generated code?
Yeah, how do you do that?
Well, the source implies that success really depends on the human's ability to guide the AI effectively, to interpret its output intelligently, and then apply the necessary human judgment and context that the AI inherently lacks.
It fundamentally shifts the competitive advantage, doesn't it? It's not just about how fast you can type code anymore, but how well you can think critically, synthesize information from multiple sources, including AI, and apply your domain knowledge and judgment effectively. This whole transition in roles, combined with what we talked about earlier, the productivity paradox, the potential for faster mistakes, it really underscores the critical importance of ensuring the quality and reliability of the code actually being produced.
That's the perfect setup for the fifth critical area the source explores, the new frontier of QA and testing. The core idea here is that testing code generated by AI demands a pretty significant evolution in our strategies, simply because its characteristics are inherently different from code written solely by humans.
How is AI-generated code different in a way that messes with traditional testing approaches?
The source describes AI code as often working on the surface, meaning, it compiles, it runs, it might even pass some basic functional checks you throw at it, but it can also be potentially fragile.
Fragile code, that sounds worrying.
Right.
Especially for long-term maintenance and reliability.
It really is. This fragility means it might work perfectly fine for this straightforward, happy path case the AI was prompted for, but then unexpectedly fail or produce subtly incorrect results when it encounters edge cases, slightly different kinds of inputs or complex interactions within the larger system that the AI didn't fully model or anticipate.
Okay, so it's brittle.
Yeah, brittle is a good word for it. And the specific challenges mentioned include the fact that AI-generated code often lacks comprehensive tests itself. The AI produces the solution, maybe, but it doesn't automatically generate a robust suite of unit tests, integration tests, end-to-end tests for that solution. And crucially, going back to the paradox, this code can silently misbehave.
Silently misbehave.
Yeah. Because you didn't write it line by line, you might not fully grasp the intricate logic the AI came up with. So issues might not cause loud crashes or obvious errors. Instead, they might produce subtle, incorrect outputs. maybe a miscalculation here, slightly wrong data there, that are incredibly hard to detect without deep system understanding or very specific checks designed to catch them.
So just relying on tests that check if the function runs and gives the expected output for a couple of standard inputs,
Yeah.
that's definitely not going to be enough anymore.
Not even close. And the source makes a really vital distinction here. Testing needs to shift its focus. It needs to move beyond purely testing the logic to testing the intent.
Testing intent. Okay, can you unpack that a bit? What does that mean in the context of AI code?
Well, testing logic is basically verifying that the code executes according to its internal structure, that it produces the mathematically or algorithmically correct output for given inputs, assuming the logic itself is sound. Testing intent, on the other hand, is about verifying that the AI-generated code actually fulfills the purpose or the requirement behind the prompt that generated it and how it's meant to function within the broader system. This includes things like non-functional requirements, security considerations, adherence to specific domain rules or constraints.
Oh, okay.
It's checking if the AI understood and correctly implemented the why behind the code, not just the what.
That sounds much harder. How do you even test the intent? That feels less concrete than testing logic.
It definitely requires different strategies, and the source provides a crucial, very illustrative example here. Imagine AI writing code that is logically valid. It fetches data correctly, maybe passes functional tests, but is also fundamentally insecure.
Oh boy. Example.
For instance, it might generate code that fetches data correctly but uses a pattern known to be vulnerable to, say, SQL injection. Or maybe it handles user input but doesn't perform proper sanitization, opening the door to cross-site scripting. The logic for getting the data might be perfectly correct according to the prompt, but the intent to do it securely was either missed by the AI or perhaps wasn't explicitly stated clearly enough in the prompt.
Wow, that really highlights that works. It's just way too low a bar. It needs to work correctly, yes, but also securely, robustly, and within all the system's implicit and explicit constraints.
Exactly right. And the source highlights mitigation strategies that become absolutely essential guardrails in this new world. Things like static analysis tools, especially those maybe trained to recognize insecure coding patterns or common anti-patterns often seen in AI-generated code, become critical first lines of defense.
Automated checks.
Yes, but human oversight, according to the source, remains paramount. Human reviewers bring that crucial system context, the security knowledge, the domain expertise that the AI inherently lacks. They are absolutely needed to perform deeper validation of the AI's generated logic against the true intent and the full set of constraints.
So QA and testing aren't becoming less important. If anything, they're becoming more sophisticated, requiring new tools, new approaches, and a different, maybe deeper kind of critical review.
Precisely. The key takeaway from the source on this point is that your test strategy must now explicitly include auditing the AI's underlying assumptions. You have to ask, what assumptions did the AI make based on my prompt and the code context it saw? Are those assumptions safe and valid for this application in this specific situation?
That's a deep question.
It is. How do you design tests or even just structure your code review processes to actively try and uncover potential fragile behavior or audit assumptions that maybe you didn't explicitly tell the AI or perhaps didn't even realize it was making? This moves testing way beyond just automated functional checks. It enters this realm of critical evaluation, assumption validation. It really requires a much deeper partnership between developers, QA folks, and security experts.
That's a significant evolution for the whole testing discipline. Now, to manage all these complexities and risks and to really leverage AI's potential effectively without shooting themselves in the foot, companies aren't just passively using the public AI tools off the shelf, are they?
No, not the leading ones. And this leads us directly into the sixth area the source explores, the rise of internal developer copilots. The core idea here is that forward-thinking companies are realizing they need to customize AI capabilities specifically for their own internal development environment.
So they're building their own AI tools, essentially, for their own developers, tailored to their specific company.
That's exactly right. The source talks about companies developing what it calls internal GPTs, or specialized AI tools that are integrated right into their internal developer platforms.
Okay, what makes these internal tools different? Why are they potentially more powerful than just using a general-purpose public model like ChatGPT or Claude? What are they trained on?
That's the key differentiator in the source of their power. These internal tools are trained on the company's own proprietary data, stuff that public models have absolutely no access to.
Like what kind of data?
We're talking about their internal API documentation, their specific libraries and frameworks that they've built, their established design systems with all the components and tokens, company-specific coding conventions and style guides, maybe even their past code repositories to learn common patterns, and potentially even internal communication logs related to project decisions or technical discussions.
Wow. Okay, so the AI actually understands the company's unique technical ecosystem, its specific jargon, its preferred ways of doing things, its internal landscape.
Exactly. It has the deep internal context that a general model simply cannot have. And the source gives a really compelling use case example for this. Imagine a developer working on a new feature, and they need to build, say, a dashboard component that has to adhere strictly to the company's design system.
A common scenario.
Right. Instead of spending time digging through internal documentation wikis, trying to find the right component library, figuring out how to import it and wire it up correctly, the developer can just query their internal AI tool. They could ask something like, how do I build a dashboard component using our standard design tokens and the approved React component library?
And the internal AI knows the answer.
Yes, because it's been trained on that company's specific design system documentation and their internal library code, it can provide tailored, accurate code snippets and guidance using the correct internal components, adhering to the established internal conventions.
That sounds incredibly powerful. For speed, obviously, but also for consistency across teams and even for onboarding new developers. It seems like it would bypass a lot of the friction points you hit when trying to navigate large, complex internal code bases and documentation sprawl.
It streamlines development significantly, yeah. It helps ensure consistency because the AI is recommending the established best practices and the right internal components. The key takeaway here from the source is that AI copilots are rapidly evolving. They're moving beyond being just generic external tools you use occasionally into becoming integrated, essential components of a company's internal developer platform, specifically tailored to their unique context, their code bases, their standards.
That really does sound like a major strategic advantage for companies that can pull it off.
Yeah.
Are there other benefits to having this kind of private, domain-specific AI assistant beyond just the tailored guidance and consistency?
Oh, yeah. Control and safety are huge factors. With an internal tool, the company maintains full control over the data it's trained on. That helps mitigate a lot of the concerns around potentially exposing proprietary code or sensitive internal data to external third-party models.
Right. The data stays in-house.
Exactly. It also gives them much more control over the AI's behavior and its outputs. This makes it easier to enforce internal standards, maybe even fine-tune the AI to avoid generating certain types of problematic code, and it could potentially help address some of those tricky licensing ambiguity concerns we mentioned earlier by ensuring the training data used is either purely internal or appropriately licensed. It essentially creates a kind of trusted AI partner that understands and respects the boundaries and specifics of that company's development world.
That control over data and behavior is a massive benefit, especially for companies dealing with sensitive intellectual property or operating under strict compliance regulations. And you mentioned onboarding. That ties into the next point, right? How does this entire AI revolution change the whole process of bringing new developers onto a team and getting them up to speed?
That's precisely the topic of the seventh section, and yeah, it significantly impacts how companies need to think about talent acquisition and integration. The core idea is that AI fundamentally alters the landscape for finding and integrating new talent. It presents both opportunities, potentially lowering some barriers, and also new challenges that require different skill sets.
Okay, let's start with the opportunities. How can AI make onboarding easier?
Well, the source suggests that LLMs can significantly lower the initial barrier to entry for someone who's new to a team, new to a complex code base, maybe even new to a particular technology stack the company uses.
How so?
A new hire can use AI tools to quickly get explanations of unfamiliar code written by others. They can ask the AI to generate initial boilerplate code or examples to help them get started on their first tasks. Or they can ask for simplified explanations of complex parts of the system architecture. This could potentially accelerate their initial productivity curve quite a bit compared to the traditional methods of just, sifting through mountains of documentation or relying solely on busy senior team members for explanations.
So the AI acts like a sort of readily available patient assistant or tutor, helping them navigate that initial, often steep learning curve.
It certainly can. However, and the source is really clear about highlighting this potential speed boost, comes with a significant new challenge. New hires need much stronger critical thinking skills right out of the gate than perhaps they did before.
Okay, why is critical thinking suddenly even more paramount for new hires now?
Because they have to be able to effectively navigate and filter all the potential AI-generated noise. They need to spot the inaccuracies, the plausible sounding but fundamentally incorrect suggestions that the AI might offer up. A new hire who relies too heavily on AI without the experience or the judgment to critically evaluate its output against reality, against the project's context, against established best practices, well, they could very easily introduce bugs, security vulnerabilities, or code that just doesn't fit the system's design or violates hidden assumptions.
Oh, they need to be able to question the AI, understand its limitations, and validate its suggestions rather than just blindly accepting them because the AI sounds confident.
Precisely. So while AI might make it easier to generate some initial code, it simultaneously requires a higher level of discernment, of critical judgment, to ensure that the generated code is actually correct, appropriate, and high quality in the context of the specific project.
The ability to critically evaluate information, regardless of where it comes from, whether it's a senior colleague, old documentation, or an AI, that skill just gets magnified in importance.
Absolutely. And this shift is already starting to impact hiring practices, according to the source material. There's a growing trend in interviews away from just pure coding challenges and towards assessing things like judgment, collaboration skills, how well can they work with others. And that now includes AI tools and system thinking. Can they understand how different pieces fit together? These aspects are becoming more important relative to just testing rote memorization of specific syntax or niche language features.
So interviews are evolving beyond just asking candidates to, like, reverse a binary tree on a whiteboard.
The emphasis is definitely shifting. It's moving towards evaluating how candidates approach problems in a way that more realistically reflects modern development, which involves collaboration, dealing with ambiguity, leveraging tools effectively, maybe asking them to debug an AI-generated code snippet and explain their reasoning, or discussing the trade-offs of a particular architectural pattern suggested by an AI, or articulating why they think one approach is better or worse in a given complex scenario.
Interesting. They're looking for the reasoning process.
Exactly. The source's key takeaway here is really insightful. AI acts as a powerful skill amplifier. It significantly boosts the capabilities of those who already possess strong foundational skills and, crucially, can effectively guide the AI, critically evaluate its output, and apply their human judgment. Success in this new era seems to depend less on raw coding speed from scratch and more on the human's ability to ask insightful questions, critically evaluate the responses they get, and synthesize information effectively.
That's a fundamental change in the profile of what makes a successful developer. But how do you actually train for something fuzzy like critical thinking? And how do companies reliably evaluate judgment in a standard interview process? That sounds tricky.
It's definitely one of the significant challenges organizations are grappling with right now. It might involve incorporating more practical, scenario-based exercises into interviews, maybe having candidates work with snippets of an existing code base, evaluate potentially problematic code, which could even be AI-generated design solutions at a higher architectural level, or simply discuss how they would approach integrating a new tool or technology, forcing them to demonstrate their reasoning and evaluation skills. It probably pushes interview formats towards more collaborative problem-solving sessions and in-depth discussions about approach, trade-offs, and decision-making rationale, rather than just focusing solely on coding quizzes.
Right. More conversation, less algorithm recitation. Okay, so all these fundamental changes we've discussed in the act of coding itself, the systems we build, the roles on teams, how we test, how we build internal tools, and how we hire, they naturally introduce a whole new set of, well, serious considerations and risks that absolutely need to be actively managed.
Absolutely. Which brings us squarely to the focus of the 8th section, navigating risks and implementing guardrails. The core idea here is stark but simple. You can't truly leverage AI effectively and sustainably unless you proactively identify and mitigate the inherent risks through thoughtful governance and well-defined processes.
Okay, let's talk risks. What are the most significant ones specifically highlighted in the source material that companies really need to be aware of and actively plan for?
The source points to two major and often interconnected risks. The first one they call hallucinated code.
Hallucinated code, like when chatbots make stuff up.
Exactly the same principle. Just as LLMs can generate text that sounds plausible but is confidently incorrect or completely fabricated, hallucinations, they can do the exact same thing with code. They might generate code that looks syntactically correct, passes the compiler, but is functionally wrong. It might reference APIs or libraries that don't actually exist, include subtle but critical logic errors, or make completely incorrect assumptions about the environment it's running in or the data it's processing.
Code that looks fine on the surface, maybe even runs, but is fundamentally flawed underneath.
That's a deeply unsettling thought for anyone worried about system reliability or security.
It's a very serious concern. And the errors introduced by this kind of hallucinated code could be particularly insidious because they don't always result in obvious crashes or clear syntax errors. They might manifest as slightly incorrect calculations, gradual data corruption over time, or unexpected behavior that only pops up under very specific, hard-to-reproduce conditions. The second major risk highlighted is licensing ambiguity.
The legal side.
Right. AI models, especially the big foundation models, are trained on absolutely massive data sets. That includes vast amounts of code scraped from the internet, places like GitHub, Stack Overflow, etc. This code comes from countless sources, all with different licenses attached, some very permissive, like MIT or Apache, others more restrictive, like the GPL, and everything in between.
Okay, so what's the problem? The problem is, when an AI generates code, especially if that generated code closely resembles patterns, structures, or even specific snippets present in its training data, there's significant legal uncertainty about the copyright and licensing status of that generated output.
So you mean using AI tools could inadvertently pull code fragments with restrictive licenses, like the GPL, into your company's proprietary project, creating major compliance headaches or even legal risks down the road?
Potentially, yes. If the AI generates code that's deemed derived from a GPL-licensed project in its training data, simply including that code in your proprietary commercial product without adhering to all the requirements of the GPL, well, that could create serious compliance problems and intellectual property issues. The source really stresses that managing these kinds of risks, both the technical risk of hallucinated code and the legal risk of licensing ambiguity, isn't just the job of a separate legal team or the IT security department. It has to be a core concern integrated directly into the product development lifecycle itself. Governance becomes a product concern.
Governance is a product concern. Okay, that means developers, architects, QA engineers, product managers, everyone involved in building the product needs to be thinking about these risks as part of their daily work. It's part of building the product correctly and safely in the first place.
Exactly. It demands a collective awareness and a shared sense of responsibility. And to help organizations actually tackle this, the source provides a kind of key checklist, a set of critical questions they absolutely must ask themselves and address in order to manage these risks effectively and establish the necessary guardrails.
Okay, let's walk through that checklist. That sounds crucial.
All right. First question on the list. Do you audit AI contributions before they are deployed? This goes right back to the QA and testing discussion. It means having formal mandatory processes, not just, optional suggestions to review AI-generated code for correctness, for security vulnerabilities, for quality issues, and for adherence to internal standards before it gets merged into the main code base or shipped out to production.
That seems like an absolute non-negotiable step, given the potential for fragile or even hallucinated code sneaking in.
It really has to be essential, yeah. Second question. Are developers properly trained on the limitations of AI tools? And this goes beyond just training them on how to use the tool, like which buttons to click. It means actively educating them on the common failure modes of LLMs when generating code. What kinds of errors do they typically make? Things like off-by-one errors, incorrect API usage, common security vulnerabilities they might introduce. They need to understand the potential for hallucination, and critically, know when they absolutely must double-check, verify assumptions, or seek human expertise rather than just blindly trusting the AI's output.
Training people on limitations.
Yeah.
Especially limitations that are constantly being discovered and evolving as the tech changes. That sounds like a continuous, ongoing challenge.
It absolutely requires a commitment to continuous learning and probably robust internal knowledge sharing about the specific AI tools being used. Okay, third question. Who is responsible for owning and reviewing the prompts used and the resulting code patterns?
Owning the prompts.
Yeah. This addresses accountability and consistency. Think about it. If a particular way of prompting the AI consistently leads to problematic code generation, who identifies that pattern? Who is responsible for changing the guidance or the standard prompts? Who ensures the prompts themselves actually align with the desired outcomes, including non-functional requirements like security? It suggests treating prompts as more than just casual one-off inputs. In complex or sensitive scenarios, they almost become like dynamic specifications that heavily influence the generated code patterns, and therefore they need some level of ownership, review, and quality control themselves.
Huh. So prompts aren't just throwaway questions. In some cases, they become part of the development artifact itself, needing management and oversight.
In complex or safety-critical scenarios, absolutely. The quality of the prompt directly significantly impacts the quality and safety of the output. So, the key takeaway from the source summarizing this whole section is really powerful, and it serves as a kind of guiding principle for navigating this whole space. The path to maturity in using AI effectively is defined by successfully balancing speed and safety. You simply cannot achieve sustainable, large-scale AI adoption and development without implementing robust constraints, controls, and processes designed specifically to ensure safety and reliability. Just chasing speed alone, ignoring the safety aspect, is basically a recipe for disaster down the line.
Maturity isn't just about being fast. It's about being fast and safe. That definitely requires a fundamentally different approach to development workflows than many might be used to.
How do organizations actually implement these kinds of rigorous processes? Auditing AI output effectively, training developers on these evolving limitations. How do they do that in a practical way, especially in a fast-paced development environment? Well, it likely involves a combination of things. Integrating more sophisticated automated tools into the CI/CD pipeline is key. Better static analysis, security linters specifically tuned for AI-generated code patterns, maybe even tools designed to scan for potential licensing issues based on code similarity. But tooling alone isn't enough. It also requires a significant cultural shift in code review practices.
How so?
Reviewers need explicit training on what to look for specifically in AI-assisted code. They need to dedicate sufficient time not just to checking functional correctness, but actively hunting for potential security flaws, edge case fragility, context misalignment, or incorrect assumptions that AI is prone to introducing. As for training on limitations, yeah, that's ongoing. It probably involves regular internal workshops, maybe sharing AI bug of the week examples to raise awareness, fostering an open environment where developers feel psychologically safe to question AI output even if it looks plausible. It's really about building an evolving, multi-layered defense strategy.
Okay, so pulling all these different threads together, now the fundamental shift in coding from writing to composing, the tricky dynamics of the productivity paradox, the necessary architectural changes for an AI age, the evolution of team roles, the new challenges in testing and QA, the strategic rise of internal AI tools, the changes in hiring and onboarding, and this absolute necessity for robust guardrails and governance. What does the source suggest is the actual strategic playbook. What should organizations do to thrive in this emerging AI-first development world?
That brings us neatly to the ninth and final section of the material, which aims to provide exactly that, actionable guidance. The core idea isn't about passively watching these changes happen, but about actively building a strategic approach to leverage AI effectively and responsibly.
Okay, so what are the key actions? What's in this playbook for AI-first development according to the source?
All right, first key action, audit workflows. Companies need to systematically go through their existing development workflows and identify the specific areas where AI assistance can provide the most tangible value with manageable risk, and then introduce it there deliberately.
Start smart.
Exactly. Is the biggest, safest win in boilerplate generation, initial documentation drafting, generating basic test cases, or maybe helping refactor legacy code. Pinpoint those high-leverage, lower-risk opportunities first.
Find where AI can give you the biggest, safest boost initially. Makes sense. What's next?
Second, train teams. This is absolutely crucial, and it loops back directly to the discussions we had about evolving roles and managing risks. Training needs to focus not just on the mechanics of using the AI tools, but very specifically on mastering effective prompt writing, that new essential interface for influencing the AI, and, just as importantly, developing really strong skills in AI code review. That critical ability to evaluate, validate, debug, and refine AI-generated output.
Right. Prompt engineering for creation, AI code review for quality assurance. Both sound like non-negotiable skills going forward.
They really are presented that way. Third action, invest in architecture. Organizations need to proactively build or evolve their system architectures so they are flexible enough and capable enough to integrate AI components and AI-driven workflows seamlessly and safely.
Be ready for AI integration.
Yeah. This means thinking about and designing for things like those prompt APIs we discussed, planning for retraining flows if needed, and building in those human-in-the-loop mechanisms right from the outset. basically anticipating the need to incorporate and manage AI capabilities as core elements of the system, not just as afterthoughts bolted on later.
Build systems that are designed to work with AI and for AI, not just tolerate it.
Well put. Fourth action. Build internal tooling. As we discussed earlier, developing custom AI tools that are specifically tailored to the company's unique code base, its internal conventions, its specific needs, that offers significant advantages. Advantages in terms of context relevance, consistency, safety, control over data, and developer onboarding. This might require a significant investment upfront, but the source suggests it yields substantial long-term returns for companies serious about leveraging AI strategically.
Create that highly specific, trusted AI assistant that actually understands your company's world.
Exactly. And the fifth key action, track metrics, but track the right metrics. It's vital to go beyond just measuring raw development speed or lines of code generated. Organizations absolutely must monitor both development velocity and things like developer confidence in the AI-assisted process.
Confidence, that's interesting.
Yeah. Are teams delivering faster? Okay, maybe. But are they confident in the quality, the correctness, the security of the code they are shipping using these tools? Is the rate of escape bugs going down or up? Is the amount of rework required decreasing or increasing? Tracking these kinds of qualitative and outcome-focused metrics provides a much more complete and honest picture of the AI's true impact on overall engineering productivity and product quality.
Speed and confidence, you really need both. This whole playbook sounds like it's specifically designed to help organizations navigate that tricky productivity paradox we discussed right at the beginning.
It absolutely is. It's a framework for harnessing the speed while managing the risks. And this strategic approach, this playbook, it brings us right back to the source's powerful, almost provocative final thought, which serves as a really concise summary of this entire transformation we've been discussing.
Okay, what is that core message? Let's hear it.
The source concludes by stating, quite directly, AI itself won't replace your development team. But a team that strategically and responsibly uses AI effectively might replace a team that doesn't.
Wow. Okay.
Yeah.
That's a strong statement and a very clear call to action. It really frames this whole AI revolution not so much as an impending technological unemployment crisis for individual developers, but more as a competitive challenge and maybe an opportunity at the team and the organizational level.
Exactly. It puts the emphasis squarely on the fact that the future isn't about being replaced by AI, but rather about the significant differential advantage that will be gained by those teams and organizations who truly master the art and science of collaborating with AI. And what does strategically and responsibly look like in practice? Well, it looks like implementing this playbook we just discussed.
Right.
Auditing your workflows, training your teams on these crucial new skills like prompting and AI code review, investing in AI-ready architecture, maybe building tailored internal tools, and constantly measuring both speed and confidence, all while prioritizing safety, quality, and governance. It really requires treating AI not just as some kind of super smart autocomplete, but as a powerful, complex, and sometimes unpredictable collaborator, one that demands significant human skill, critical judgment, and careful oversight to unlock its true potential safely and effectively.
That really provides a comprehensive picture of how AI is profoundly reshaping the world of software development, drawing directly from the insights in the strategic overview we've been digging into. We've covered a lot of ground here.
You have.
We've journeyed from that fundamental shift in the act of coding itself, moving from primarily writing to composing, curating, and prompting. We navigated the nuances of the productivity paradox, where speed absolutely must be balanced with quality and context. We looked at the evolution of architecture to become more AI native, designed for AI interaction.
We discussed the reshaping of familiar team roles with the value shifting towards judgment, synthesis, and review. We explored the new frontiers in testing and QA required for fragile AI-generated code.
Right. And the strategic advantage that comes from building tailored internal AI tools. The altered landscape for hiring and onboarding new talent, emphasizing critical thinking. And finally, that critical necessity of implementing robust guardrails and governance to navigate the inherent risks safely.
And throughout all of that, the overarching message that comes through loud and clear is this. Developers aren't necessarily on a path to being replaced by AI itself, but the fundamental nature of their work is changing profoundly. It demands an evolution of skills, a shift towards those higher-order cognitive abilities like critical thinking, deep judgment, effective prompting, and rigorous context-aware review.
And so we leave you with that powerful final thought from the source material, maybe echoing in your mind now. AI won't replace your dev team, but a team using AI strategically and responsibly might just replace one that isn't.
Which leaves us all, especially if you're involved in building software or leading technical teams, with a pretty compelling question to ponder. Given everything we've discussed today, how are you preparing for this AI-transformed world of software development? What specific skills are you focusing on developing, either in yourself or within your team, to ensure that you are part of the group that embraces AI effectively, safely, and strategically, not just to keep pace, but potentially to lead the way?
Something significant to consider indeed. That's all for this deep dive. Thanks for joining us.
Until next